All right. So let's go ahead and start now. Now again, I know I have up here a graph. I don't care about the graphing. Everybody can do a number line. All right, so you'll be responsible for just doing interval notation. All right. Now remember, I'm expecting you to get better at the numbers. All right. Now remember what I told you. I want the variable to be positive. Great. So let's move the 3x over. We end up with 4x. And then you're adding 7. Dividing by 4. And so now we know x is what? Greater than or equal to 4. Perfect. X is greater than or equal to 4. Yes.
So x is usually on the left?
Yeah, yes, I would say that's always true. We want the variable on the left. So now we have a bracket for to infinity. All right, move on. Number 2. Distributing a negative 5. Just turn it off and turn it back on. Turn the Wi-Fi on and off if you're having trouble.
Okay.
Shh, just leave them alone. All right? Now, from there, we're going to add 3x or add 5x to both sides and subtracting 1. And now when you solve it, we would say x is greater than negative 7. And if you're greater than negative 7 to infinity. So far, so good? All right, let's try the next one. This one's a nice one. All you got to do is move the 6. X is greater than or equal to negative 12. Everybody go with that?
Yep.
If we're greater than or equal to negative 12, we start at negative 12, and we head off to infinity. Number 4, distributing a negative 4.
Could you also just divide the negative 12 by negative 4?
Which one?
On the
Oh. Listen, now, if you were to divide by negative 4, you would also have to do it on the 2.
Oh, you would? Oh,
Yeah.
okay.
So that wouldn't be to an advantage because that would create a decimal or another fraction. All right? So that's good. Good question. All right, so let's just distribute. 2x minus 12x plus 32 is less than negative 12. And so now are you with me? Negative 10x is less than negative 44. Is that good? And so if you divide by negative 10, you have to do what to the sign? So x is greater than 44 over 10, which is the same as 22 over what? 5. Are we okay with that? And now if you're greater than 22 over 5, you would start at and head out to infinity. All right, everybody try 5, 6, and 7 real quick. Everybody do 5, 6, and 7. All right, everybody check out number 5. See how you did. Any questions with number 5? Double check yourself. All right, let's check out number 6. Let's see how you did on that. Bless you. So here we go. How's that? Very good. You're greater than -8. -8 to infinity. Everybody good on that? All right, speak up now, please. All right, let's check out number 7, see how you did on that one. Does that look right? What's the matter?
I thought that like when it's like that, it's like real or not real.
No. So if x is less than or equal to 0, it goes from
0 or negative.
-infinity to 0. Are we okay with that? Any questions? All right. Let's give you a chance here to knock out 8 real quick. All right, so for question number 8, distribute the -4. All right, combine like terms, what do we get? -7x, is that correct? And then it would be plus 33 is less than -12 plus 6x. Everybody good with this? And now, keeping the variable positive, we would have 13x. You add 12, you get what? Anybody have any questions so far? And so now, again, unusual, but we can have a fraction, 45 over 13. And so now x is greater than 45 over 13. Anybody have any questions with that? X is greater than 45 over 13. Interval notation, we're starting at what? 45 over 13 and heading out towards infinity. Any questions on that so far? All right, move up. All right, now number 9, I'm not going to put this on the test. I mean, these questions are going to be on the test, but I'm not going to have think next to them. All right, you're going to have to recognize what the solution is here. All right, so somebody be brave. Tell me what the answer is for number 9. Yes, sir. Is it no solution?
Oh, no.
I'm not saying you're right or wrong.
No, it's not.
What is it?
It's
Well, no. Come on now, don't let me change your answer just because I just ask a question. What happens to the 3 x's? Right? They can cancel, but more importantly, you can say, okay, if I take a number and add 9, is it going to be less than or equal to that number minus 7?
No.
No. Do you agree with that? All right. This 3x plus 9 is always greater than what? 3x minus 7. So the answer is what? No solution. All right, number 9, definitely no solution. 9 is definitely no solution. Now remember, it's when you're taking your test on Thursday, you're going to have to think about that. All right. Now another way you can remember it is what happens to the 3 x's? They're going to cancel out, right? So now you're just looking at the numbers. All right. Now on number 10. Number 10, we would say
all real numbers.
Because
The 2 x's cancel each other out, so you get 1 is greater than -8 and 1 is greater than -8.
1 is always greater than -8. All right, 1 is always greater than -8. So we would say, remember, negative infinity to infinity, or you can write the symbol all real numbers. All right, that's not too bad. All right, a couple more now. I want everybody to try 11 and 12 and see if you can come up with the right answer. All right, everybody try 11, everybody try 12. All right, when we distribute, 6x is greater than -12 plus 6x. What do we got on this one, Dalton? 0 is always greater than -12. All real numbers. All right. So let's see how you did on number 12. Let's distribute here. Combining like terms. So here, Tyler, I think you're correct. 32 is not less than -12. So that's no solution. All right. Remember, please look over these special cases. All right, look over the special cases. Anybody confused with that? Anybody have an issue? Any questions? All right, here we go. Now you should be able to quickly write the answers here for 13 through 16. All right. Remember, these are the compound inequalities. All right, how do we know they're compound? Because it has the word or and, or it's written in this format like number 14. You should recognize that as an and statement. All right. Now remember, the idea for you is to make sure that you're seeing the numbers better. All right? That you're seeing the numbers better. So when somebody says to you, what are the numbers less than -2 or greater than 5, you should be able to tell them that it's from negative infinity to negative 2, union 5 to infinity. All right, yes.
Could you put instead of the union in the middle 4?
Well, I'm not going to argue about that. I just want you to know that if you were looking up in a math book, that's the way they would write it.
Okay.
All right? That U is union, which just basically means put things together. All right? It's these answers with these answers. All right? Now, number 14, that's definitely an and statement. Go.
So you put the U when it's 4.
Yes, very good.
Always.
How else would we write it? See what I'm saying? There is no other symbol. All right? So on number 14, if we're writing it in interval notation, it would just be negative 3, comma, 7, brackets. Everybody good with that? All right, that's pretty straightforward. So those are the two basic ones that you have to know for these compound inequalities. All right, now for question number 15, here's where we have to solve them out. All right, so 15, you just add 12. So you would say 3x is less than negative 36. So x is less than negative 12. Then you solve the other problem by adding 7. So you would say 2x is greater than 28. And so x is greater than what? 14. Now, you're supposed to be able to look at that and say, are you going in opposite directions or are you going in the same direction? You're going in opposite directions. All right? So we know that we're going from negative infinity to negative 12, union 14 to infinity. Everybody okay with that? Yes, sir.
What happens if they're going in the same direction?
We're going to get to a couple of those harder problems. All right? We'll talk about it in a minute. All right. So on number 16, we just have to do what? Well, you can do that, but in this case,
Divide by 2.
yeah, you can just divide by 2 because there's not variables in all 3 sections. You with me? So here we would just divide everything by 2. So I'm just going to write it down just to make sure everybody's clear. So negative 2 is less than or equal to x, less than or equal to 4. Right? So that's your and statement. X is between what two numbers? Between negative 2 and 4. All right? Yes.
If it was negative 2x, would you flip all the signs?
Very good. Multiplying or dividing by a negative, you change the signs. All right, so now I want everybody to try 17, 18, and 19. Let me give you a minute on 17, 18, and 19. Everybody get a shot. Let's go. 17, 18, 19. And then just be careful on that. right, let's see how you're doing. All right, number 17, I think is pretty straightforward, right? So we just have negative 4x is greater than negative 8. So x is what? Yeah, don't forget, less than 2. And over here we have 5x is greater than, so x is greater than 9. So are these heading in opposite directions?
No. Yes.
Are they heading in opposite directions? Yes. Do you agree? What?
Can you just like for the first problem, could you divide by -4?
Yeah, some of you guys are starting to see that. Yes, that is absolutely true. All right. So now we have from negative infinity to 2, and then from 9 to infinity. Easy enough, right, guys? All right, now on 18, what can I do?
Add 7 to both sides.
Add 7. So we get negative 12 less than or equal to 3x.
And then you divide by 3.
And divide by 3. Perfect. Everybody go with this? So that just means x is between negative 4 and 5. Everybody good with that? All right, now the one I think that's kind of important is when is a number less than negative 2 and greater than 2? We would say what? None of them. No solution. All right? Take a look at that. Make sure you understand that. Do I need to explain anything for you on that? Anybody have any issues with that? Yes.
So this one, if it was an or, it would have done like the.
Now, or is going to come up, I think, in a few minutes. But the answer would be completely different if it's an or statement. Well, you tell me a number that's less than negative 2 and greater than 2.
Oh, because it's an answer.
Right. Right. There is no number less than negative 2 and also greater than 2. You agree with that?
Mm-hmm.
All right. There's another kind of trickier question, okay? Now, 27, or actually, I think I wrote these just for extra practice. So I want everybody quickly to do 20 through 24. Those are pretty straightforward. Do 20 through 24 real quick. All right? And you can see how you're doing. Be careful with the signs. All right, so again, the first couple should be pretty straightforward. Again, you should be seeing these better now. So we'd say from what? Negative infinity to negative 7. And then we would say from 6 to infinity. All right, number 21, we would just say x is between negative 9 and negative 7. Everybody happy with that so far? So far, so good? All right, now 22. Don't be confused by 22. All right, adding 14, so we get 7x is less than negative 28, right? And so now, and 6x is greater than 36, x is greater than 6. So we're heading in opposite directions? Yeah. So we have negative infinity to negative 4, 6 to infinity. Everybody good with this? All right, let's take a look now at 23. 23, I can just do what?
Divide by 6.
Yeah, divide by 6 for me when I do that. So now I'm just between what?
Negative 2 and 3.
Negative 2 and 3. Everybody see that's easy. All right. I think we should be good. All right, let's take a look now at, let me give you a minute real quick, do 24, 25, and kind of think about 26 now. Think about 26, 24, 25, and 26. Especially number 26. Put a little thought before you write down an answer. Well, no, not yet. That's correct. Now you write X. Then change this. Then change that. Instead of being positive, the value, whether it's positive or negative. Yeah, there you go. Okay. All right, 24 and 25 shouldn't be that bad. 26, if you get 26 correct, you're pretty good with numbers. All right, you understand pretty well. All right, let's look at 24. First thing, negative x is greater than 3, correct? And then we would say x is less than negative 3. X is less than negative 3. Everybody good with this? Good? All right, and now negative x is less than or equal to negative 5, right? And so now what? Beautiful. Are you going in opposite directions?
Yeah.
Yeah. All right, so here we go. Negative infinity to negative 3. And from Everybody pretty happy with that?
Mm-hmm.
All right, on number 25, we can just go ahead and add 8. And then divide by 8. Everybody happy with that? So that just means x is between negative 2 and 3. Easy enough. All right. All right, here we go. For question 26. For question 26. What do you think?
-2 to 2.
Negative 2 to 2. Patrick, what do you think?
Bracket negative 2.
What do you think? All real numbers?
Negative infinity to 2, negative 2 to infinity.
What do you think? All real numbers.
Yes.
Yeah. All real numbers. All real numbers. Now again, what I want to do is I want to try to show you this now so you can see exactly, all right, what we're thinking about. Now you really can't understand this unless you're thinking about all of the different possibilities. So here's what I want you to do. Normally I don't say put a number line down, but we're going to go ahead and put a number line down in this case. All right. And then if I am less, well, essentially what I do is I try to show kids we have 3 different possibilities here. Right? I have 3 different possibilities. I have less than negative 2. And then I want you to think about this. I have the numbers between negative 2 and what? 2. And then I have the numbers that are greater than 2. So everybody take a look at that, please. All right. Now, to me, this is how I first figured out exactly I could always get the questions correct. Always. Because I knew and meant that it had to be true for what? Both of them. And or just meant that it had to be true for what? One of them. That's it. Could it also be true for both of them? Yes. All right. So now I'm going to pick a number, and here's where I need you to try to listen to me. I need to pick a number in this range right here. So what would be a good number to pick? Negative 3. So does negative 3 work?
Yes.
Is negative 3 less than 2?
Yes.
So that means all of these numbers will work. Now I pick a number between negative 2 and 2. What's a good number between negative 2 and 2?
1.
0. If you chose 1, that's good too. Let's try 0. Is 0 less than 2?
Yes.
So automatically all of those numbers work. Right? Now we have to pick a number in the green region. What is that? 3. Is 3 less than 2?
No.
No. Is 3 greater than negative 2?
Yes.
Yes. So that's why it's what? All real numbers. All real numbers. All right? Please take a look at that now. And if you didn't quite understand what I said, I want you to listen to the video again. All right? And just hear what I'm trying to tell you on that. Very important for your understanding of numbers. I don't think it's that hard. All right? Or statement can be true for one or the other. Now, would anybody like me to repeat that real quick? Anybody like me to repeat it? Go.
So, because it works for all of the numbers,
That's why it's all real numbers. In other words, you can't give me a number that's not less than 2 or greater than negative 2. No matter how hard you try. It's true for one of those. Do you agree? All right, that's why. All right. Now, on one of the tests, the absolute values were the hardest problems. All right, so it's not going to be hard anymore. All right, there's just one additional step. It's an absolute value inequality. So to solve an absolute value inequality, you have to write 3x minus 6 is greater than 12, and 3x minus 6 is what? Less than negative 12. Make yourself a note. You need both equations this time. Every absolute value inequality requires 2 equations. All right? Anybody have any issues? And now once you break it down to this, of course, it's just like what we were doing before. It's easy. All right? So let's knock this down and make sure we're good. So we say 3x is greater than 18, so x is greater than 6. 3x is less than negative 6, so x is less than what? Would this be an and or an or statement?
Or.
Definitely or, because they're going in opposite directions. So we would say from negative infinity to negative 2, then from 6 to infinity. Everybody okay with that? Absolute value inequalities require 2 statements. Any issues? Okay, number 28. Number 28. All right, we're going to write it. 4x minus 20 is less than 8. 4x minus 20 is greater than negative 8. Very good. Now solving it out, you should be getting faster and faster at solving equations. 4x less than 28, so x is less than 7. 4x is greater than 12, so x is greater than 3. So is this an and or an or?
Or.
And.
I think it's and, right? And the reason why we say it's and is because they're running towards each other. They're going towards each other. Everybody see that? So that means you're greater than 3 and you're what? Less than 7.
Wouldn't that also be all the numbers?
Not if it's an and statement.
Oh, yeah.
Right. Now, number 29. What do I need to do on 29? Divide by 3 first. You isolate the radical. Isolate the radical. So we're going to say absolute value of 2 minus x is less than or equal to 2. I said radical. I meant isolate the absolute value. All right, so let me give you a minute for everybody to do 29, 30, and 31. Try 29, 30, and 31. Should be pretty straightforward, pretty easy. So. This is how I want you to set it up. Write them side by side, not down. Right? Write them side by side. It's much easier. All right, so for 29, remember we write 2 minus x is less than or equal to 2, and then write 2 minus x is greater than or equal to negative 2. Everybody feel good about that? And then subtract 2, so we'd have negative x is less than or equal to 0, right? And so x is greater than or equal to 0, right? And now, negative x is greater than or equal to negative 4, so x is less than or equal to 4. So again, this would just be everything between what?
0 and 4.
Is everybody okay with this? Everything between 0 and 4.
Why would it be?
It is an and statement.
Why? I mean, why? Yeah, why is it? Because it's everything between 0 and 4.
Well, because if you're thinking about it, and this goes back to understanding the number line, right? If we say, for example, I said if the absolute value of x is less than 2, what? if the absolute value of x is less than 2, it would be the numbers between -2 and 2. Right? It would be these numbers here. You agree with that? Because once I move over here, once I move beyond -2, less than -2, if I take the absolute value, that's greater than 2. You with me now? All right, that's why it's an and statement. Yes. Yes, that's exactly correct. All right. So now on 30, we would just go ahead and write 9x minus 18 is greater than or equal to 27. 9x minus 18 is less than or equal to what? -27. And now 9x greater than or equal to 45. So x is greater than or equal to 5. And then 9x is less than or equal to -9. So x is less than or equal to -1. Are we good with this? So we know this is a what? Or statement. -infinity to -1. And then we would say from 5 to infinity. Anybody have any issues? I'm listening.
How do you like see the or right away? You just have to see.
Well, the reason I see it right away is because the numbers. Can you be greater than 5 and less than -1? That's why it has to be an or statement. You can't be in both spots. You can't be greater than 5 and less than -1. Do you agree?
Yeah.
That's how you tell. That's the easiest way to think about it. All right? You cannot be greater than 5 and less than -1. Right now. So one more time. I can tell if it's an and statement if it's true for both of the sentences. You with me?
Yeah.
In this case, I know it's not an and because I can't be greater than 5 and less than -1.
Yeah.
Right? We're on these problems right here. 1 is greater than or equal to 0 and less than 4. Right? Between there, it's true for both of them. All right. I know Isabel getting ready to ring.
Yeah.
Yeah. Okay. So guys, listen. Your job. Try to think about the rest of them. All right. And then we'll just discuss it tomorrow. Yeah. You're studying. You are studying. That's what you're doing. The test is Thursday. It'll be just like this right here.
Thank you, Mr. Sharp.
You're welcome. Good job today.